squeeze too much. Are we okay? All right, so let's talk about function notation. What is this? Well, as I said, math is a language. When you talk about language, it's not just talking. There is also the grammatical part. There are ways to write ideas. Okay, it's a way that you write things. So the same thing happens in math. We have a way to write information about functions, a way to write functions. Writing set of other pairs is really not convenient because sometimes we don't even know those, or they are infinitely many. Sometimes, usually what we know is the equation or the graph. If you know the graph, you graph it and then you're good. But what if you have the equation? Okay, so let's write this down. So let me start this with a question. So what is the value of y equals x plus 2 when x is 3? So, very silly question. But it illustrates what we're about to do. So who can answer this? What's the value? What is it? 5. Very good. In other words, all I'm asking you here is tell me what is y when x is 3. Yes? That's what I'm saying. So the answer here is answer, well, y equals 5. Since all you do is you put a 3 where you see the x and then you write 5. Okay? We actually have a way of writing this down. Okay? Instead of me having to ask you this question, we have a little symbol that allows to write something like this. Okay? So this question can be asked as follows. First of all, notation. Let me introduce the notation, and then we're going to rephrase this question in function notation. So we write, so if y is a function of x, which in this case it is, right? For each x, there is only one y. Just do plus 2. You get one y, okay? So if y is a function of x, then we write the following. First of all, functions, typically we give them names, and the names that we give them are letters, and typically we use lowercase letters, okay? The most commonly used one is f, but if there are many functions around, sometimes we use f, then g, then h, and if you want to work with more than 3 functions, then you need to keep on, using other letters, okay? So typically we use f, and then we write this. We write y equals f, parentheses, and then we put x inside. This reads as f of x. Y equals f of x. So it reads as y equals f of x. That's how you read it, okay? Now, this f is just a name for the function. So this is the name of the function. So, we use a lowercase of f, g, h, whatever letter that you want. Now, x is x and y is y. Now, x represents the input. The way that you should think about a function is like a machine. So when you have a machine, what is it that you do? You feed it some sort of input, and then you're expecting an output out of it, okay? And we want a well-behaved machine. What do we mean by a well-behaved machine? We want a machine that if I fit in this pencil, I always get the same thing. So I know that when I put a pencil, I'm gonna get the same thing on the other side. You don't wanna put a pencil and get a cat, and then put a pencil and get a dog. You wanna know what to expect before you actually put in the pencil, okay? So that's why you need, for each input, there is only one output, okay? Otherwise, it's not a well-behaved thing. You cannot control it. So inside the parentheses here represents the input. So this is the input, okay, which represents, the domain, and this right here, so the whole thing, we call it the output, which represents the range, okay, which represents the range. All right, so this is what function notation is. So I guess, let me draw a little picture. And this is going to be handy when we talk about composition and inverse functions. So again, you can think of a function as a little machine. Let's say this is the function f, and then, x is the input, something comes in, and then what comes out is the output that we call it f of x. So that's the input, output. Okay? All right. So the point is that inside the parentheses you put the stuff that you are allowed to plug in, so the domain, and the result is what we call the range. So we can easily ask this question now by asking, first of all, it's understood that y equal f of x. In other words, it's equal x plus 2. And the question that we are asking is, what is f of 3? Okay? So if you see this, what I'm asking you is, when the input is 3, tell me what is the output. Do you understand this? So how do we write the answer then? How do we write the answer? We say f of 3 equals 5. In other words, when you write something like this, what you're telling me is that when x is 3, y is 5. Equivalently, the point 3, 5 is a point on the graph of the function. Or the point 3, 5 is a solution to the equation. So this right here is telling you a lot of stuff. Okay? It's telling you when x is 3, y is 5, but it's also telling you that the point 3, 5 is on the graph of whatever this function is. Do you understand what I'm saying? Yes? Okay. Good. So let's do some examples. So example, find the indicated values. And let's see, we have f of x equals x squared minus 3x plus 5. So typically that's how it works. So we're calling this function f, and then f of x is equal to some formula that only depends on the variable, the input variable, okay, x. This is called, let me go back here. The input is called or referred as the independent variable. Independent variable, so you're free to pick whatever you want here, as long as it is okay according to the formula. But then the output depends on the input. So depending on the x that you give me, that's the output that you obtain. So this is called the dependent variable. Okay? Dependent variable. Okay. So we have f of x equals x squared minus 3x plus 5. And then let's find f of 0. And let's find f of negative 2. I'm going to do this one, and then I'm going to give you another one for you to do. So again, when you see this, what's the question that we are asking? What question are we asking here?
What f of x is equal to when x equals 0?
In other words, what's the y corresponding to x equals 0, right?
What's the y intercept then?
So when x is 0, what is y? That's the question that we are asking. Remember, this stands for y. Yes? So how do you figure this out? Exactly what we did before. This means go to the function, whatever formula you have, every place that you see an x, you replace it by what you have inside this parenthesis. Do you understand this? That's what this means. This means go to the formula and replace x by 0 in this case. In other words, my advice to you is, because later we're going to be plugging in all the stuff, all the numbers, like the things here will be a little bit more involved. So whenever this happens, my advice to you is, this just means go to x and replace it by this. So put parentheses, rewrite your formula with parentheses instead of x, okay? And then inside the parentheses, you write whatever you have in here. That way you don't get confused later on. So that's something squared minus 3 times, that's something plus 5. That's really what that formula means, okay? And then it turns out that what we're plugging in now is just 0. So the answer is, of course, 5. So f of 0 equals 5. Do you understand this? So again, this means that the point, so the point 0, 5 is on the graph. Okay? All right, so same thing for -2. So I'm gonna put my parentheses because it's good practice to do so. Okay, so what do we get? So we get 4 plus 6 plus 5. So the value is 15. Okay, good. So let's see, do this one. So do this. Let me write down the examples that I want you to do. So find f of 3, find f of -1. So you can start working on this. And for this one, find this. And I'm serious about what I just wrote in there. Okay? So do 2 and 3. What's the answer to the first one? What's f of 3? Well, let's see. We have -3. So the negatives outside. 3 squared and -5 times 3 minus 2. So what is this? That's -9 minus 15 minus 2. So what do we get? -26. Be careful. If you don't use parentheses, you're going to get the answers wrong. Okay? So again, when you're plugging in, every place that you see an X, put a parenthesis. And then inside the parentheses, you fill in whatever your input is. Here, this negative is not affected by the square. Do you understand this? It's only the X what is being affected by the square. So that's why writing parentheses is important. Okay, questions about part A? About part B? What do we get? What is it? +2? Okay, let's see. So this will be minus -1 squared minus 5 minus 1 minus 2. So what do we have here? It's -1 plus 5 minus 2. So that's 5 minus 3, which is 2. Good. All right. Questions? Okay. How about number 3? What do we need to do to answer this question?
Substitute X with minus.
Exactly. Does everybody understand this? Remember, this is just, this here what I'm telling you is go to whatever the formula is, and if you see an X, put the symbol. Whatever that symbol is. Okay? It could be an expression, it could be a number, it could be smiley face. Whatever. Okay? Now, whether it has a meaning or not, that's a different story. Okay? The result, whether it has a meaning or not, that's a different story. But this just means go here and replace X like this. Okay? So that's the mindset that you need to have when you are doing it. This is called evaluating the function. Okay? So here, just go every place that you see this, that you see an X, put a parenthesis. And then inside the parenthesis, you put whatever you're given. In this case, we're giving a smiley face. That's what we write. Now,
that's a very happy function.
All functions are happy. So what this means? Well, I don't know, right? So what smiley face cube? Well, it's 3 times happy. I don't know. But the point is that this just means go there and plug in. Okay? So let's use this idea now. So evaluate and simplify. And so let's see. We have for f of x equals 2x squared minus 3x. Find f of x plus 1. F of x equals 3x squared minus 1. Find f of 2x minus 3. F of x equals 2x over x squared plus 1. Then find f of negative x. And then for f of x equals 2x minus 3, try first to find f of x plus h. And then second, find f of x plus h minus f of x. Okay. All right, so I'm going to do the first one, then I'm going to give you some time to compute the others. Okay? So again, as I said, what does this mean? What does this mean?
Substitute x with x plus one.
Exactly. Go to the function, every place that you see an x, just write an x plus 1. Okay? And then simplify. So let's see. Let's do it. So solution. For the first one, we want to find f of x plus 1. Well, this is my equation. It's just instead of x, I put parentheses, and then inside the parentheses, I put 1 given. I'm giving x plus 1, that's why I write x plus 1. Now, our job is to simplify. Now the rest is just algebra. Well, all of this is algebra. So x squared plus 2x plus 1, that's binomial. And then minus 3x minus 3. So you get 2x squared plus 4x plus 2 minus 3x minus 3. So f of x plus 1 is going to be 2x squared plus x minus 1. Right. Any questions? Do you understand this? In other words, out of the formula, out of the function, you can obtain new functions. Okay? So out of this function, 2x squared minus 3x, we obtain this one, 2x squared plus x minus 1. And we obtain that by evaluating this function at x plus 1. When we talk about graph in the next section, transformations and so on, let's see, who remembers this? Because I know that most of you have seen these things already. So, what's the graph of this function when you compare it with respect to this one? Does anybody know what's happening here? Yes?
If I remember correctly, it is shifted upwards by 1 unit.
No, it's a horizontal shift. So it's shift to the left by 1 unit. Okay?
Plus one.
So this is a function, it has some picture. This new function, which is this one down here that we are obtaining, is basically this function shifted to the left 1 unit. Okay? We're going to be playing with this in the next section. That's called transformations of graphs. Okay? So that's why it's important to understand function notation, because we're going to be writing this stuff a lot. Okay, are there any questions about part A? Okay, go ahead and do B and C. Okay, so who can tell me what do I write? And don't give me the answer. Tell me what should I write here?
3 parentheses 2x minus 3 parentheses squared minus 1.
Does everybody understand this? This is the first step. Does everybody understand this? Okay? All right, good. And after this, it's just simplifying. So that's 4x squared minus 12x plus 9 minus 1 distribute. That's going to be 12x squared minus 36x. Then we have 27. 27 minus 1 is 26. Questions? No? Okay. So how about the next one? So the next one was 2x over x squared plus 1 okay? And we wanted to figure out f of negative x. Let's see, let me poke your memory. So does anybody remember why is this helpful? What are we trying to figure out by evaluating f and negative x? Say that again? No.
You're reflecting it across the y-axis.
Yes and no. It will give you some information about it. But yeah, more or less.
Oh, if it's an odd or even.
Exactly. Here we're trying to figure out the symmetry of the function, whether it's even or odd. Even would be if it's symmetry with respect to the y-axis, but odd it will tell you symmetry with respect to the origin. We'll talk about these things in the next chapter, in the next section. Okay. But the thing is that you need to be able to have the skill of giving a function, evaluate this, because if you want to determine whether this has some sort of symmetry, in particular even or odd, this is what you need to compute. Okay? Then depending on what you obtain, you make a decision. Okay? Anyways, what should I write here? We'll talk about what I just said later. Alright? Just giving you a little preview of the things that we'll be discussing. And to see if you know these things or not. Okay, what is this equal to? What do I write? So, let me make sure that somebody else can tell me this.
-2 over 2.
Tell me what do I write in the next step?
So 2 parentheses, -1, and then over.
Negative x.
Oh, okay.
It's different. There is no one here. Yes? So it's not the same. So negative x over. So negative x squared plus 1. Yes? And then you evaluate. So we get negative 2x over x squared plus 1. Okay. Questions? All right. And then how about the last one? By the way, this will mean, if you don't remember, this will mean that this function is odd. Okay? Because notice that what we obtained here was minus the function itself. So if you look at the function, you multiply by -1, this is exactly what you get. This tells you the graph is also symmetric with respect to the origin. So whatever happens in quadrant 1 is going to mirror over to quadrant 3. Whatever happens in quadrant 2 mirrors over to quadrant 4. Okay? All right, so that's that. And then the other one was 2x minus 3. For example, this computation that we're about to do is going to be helpful later when we talk about average rate of change, but you're going to use it several times in calculus. When you talk about the notion of derivative, there is an expression that you have to compute, and that expression is the difference quotient. And difference quotient is this divided by h. Okay? So you have to be able to evaluate stuff like this given a function. All right. So who can tell me what do I write in the first one? What do I write? This?
Well, no, in parentheses.
So tell me what I write. So what do I write?
2x plus 2h minus 3.
Okay, so 2 parentheses x plus h and then minus 3. Yes? Remember, you have no idea how many times students make mistakes doing these things. Okay? That's why I'm emphasizing this a lot. So then distribute, you get 2x plus 2h minus 3. And here there's really nothing to do. So there is nothing to simplify. Now for the next one, you do the same thing. So this part right here is f of x plus h, and then minus f of x. In other words, that's minus the function. Now because f of x is, is 2 terms, then you need to put parentheses around, because this negative is going to affect the sign of everything around. And then, evaluate. So 2x plus 2h minus 3 minus 2x plus 3. This guy cancel out, this guy cancel out, so you get 2h.